guys, welcome to another lecture from ecopoint. Continuing the series of vectors that we were working on, today I want to discuss with you, with the help of a question, let's figure out how to determine whether two lines intersect. We were talking about lines in Rn, remember? So, how to determine whether two lines intersect. Suppose we have lines x, y, z equal to 310 plus t times 201. Remember how to represent lines in Rn? And suppose we have another one, xyz equals to 1 minus 1, 5 plus s times 2, 1 minus 2. Do they intersect? If yes, let's also find the point of intersection. Logically speaking, when two lines intersect, then at that particular point, they're equal, right? So that means the two lines intersect if and only if there exists at least one TS belonging to R such that the two parametric forms are equal. So 310 plus t times 201 is equal to 1 minus 1, 5 plus s times 2, 1 minus 2. Now what we can do is we can get this here and we can get this here. So this would become t times 201 minus s times 2, 1 minus 2 is equal to, you know how to add or subtract vectors? So 1 minus 3 minus 1 minus 1, 5 minus 0, that is equals to minus 2 minus 2, 5. Now, if you observe, we actually have a set of equations. If you observe, this is your left hand side and this is the right hand side. So you have 2t minus 2s, 0t minus s, t plus 2s. That's your left hand side, and the right hand side is minus 2 minus 2, 5, which gives us three equations. 2t minus 2s equals to minus 2, minus s equals to minus 2, t plus 2s equals to 5. Also, this can be represented, either you just solve from these equations or you can represent it in terms of or either you can solve from these equations or you can represent it in matrix form. Remember, if we have these equations, we can write them as 2, 0, 1. This is for t and this column is for s. So it's going to be minus 2, minus 1, 2. And the augmented form, right hand side is minus 2, 5. Now you can solve for these equations using the matrix methods. So row operations can help you in reducing this. So the first operation that I will do is swap. I will swap, and that will give me 1, 2, 5 on the top. 0 minus 1 minus 2 as it is. 1, 2 minus 2 minus 2 here. And why I'm doing that? So that I have a 1 here. Now with this one, I'm going to make this 0. So R3 goes to R3 minus 2 R1. And that gives us 1, 2, 5. 0 minus 1 minus 2 as it is. And here you get a 0. Here you get minus 2. Minus 4 gives you minus 6. Minus 2. Minus 10 gives you minus 12. Now, if you observe, the last row can actually be taken off because it's redundant. Why? Because R3, if I use the operation, R3 goes to R3 minus 6 times R2. You will get 1, 2, 5, 0, minus 1, minus 2, 0, 0, 0. Because that will give you 6, adding 6 here, adding 12 here. Okay. And therefore, what you get now from back substitution, you can figure out from here that minus s is equal to minus 2. That means s is equal to 2. Once you move to the first equation, you will get t is equal to 5 minus 2s, that is 5 minus 4, that is 1. So which means that we have a unique solution. Since we have a unique solution for T and S, therefore the lines intersect. So the lines definitely intersect. Now, how do you get to know the point of intersection? Where are these lines intersecting? To get the point of intersection, what you can do is you can actually plug in the value of T or equivalently of S. So if I put T equals to 1, I get, remember, it was X, Y, Z line is 310 plus T times 201. So if I put T equals to 1, so I'm going to get 310 plus 1 time 201. So this gives me 511. This is your point of intersection. Okay, this is the point of intersection. If you put S equals to 2, you will again get the same thing. Let me go back where we had the line with S. So if you put S equals to 2, see what you get? You get 1 plus 4, that is 5, minus 1 plus 4, minus 1 plus 2 gives you 1. 5 minus 4 gives you 1. Again, you get 511. So 511 is the point of intersection. These were two lines in R3, as you can see. Okay. And these do have a point of intersection. So sometimes you will get this unique solution and you know that there is one point of intersection. Sometimes you can have many solutions, right? So if you have infinitely many solutions, that would mean that it's the same line, they're coinciding. And in case there is a no solution, that means they do not intersect. So anything is possible. Now there is another form for line which is useful. Which is called the symmetric form. Now, what is symmetric form? X is equal to 1 plus 2t. Y is equal to 1 minus t. Z is equal to 3 plus 2t. Now, where is this coming from? This is, suppose, the line given to you. Consider the line given by x equals to 1 plus 2t, y equals to 1 minus t, z equals to 3 plus 2t. It's just your parametric form x, y, z written like this. Okay. Now we can solve. We can solve each of these equations for t. So from the first one, I will get t is equal to x minus 1 upon 2. From the second one, I will get t is equal to 1 minus y. And from the third one, I will get t is equal to z minus 3 upon 2. Right? So, these are the three t's that you get, but they all have to be equal. They are from the same parametric form, right? So, therefore, the symmetric form is defined to be x minus 1 upon 2, this value of t equal to 1 minus y. Instead of 1 minus y, to write it down in a proportion form, in a fraction form, I'm going to take y minus 1 upon minus 1. The form, symmetric form, is generally given as x minus y first. Similarly, z minus 3 by 2. So this is how you write the symmetric form of a line. So consider the line whose equations are given in symmetric form. As x minus 2 upon 3 equals to y minus 1 upon 2 equals to z plus 3 upon 1. Find the parametric and vector equation of this line. So for parametric form, what we need to do, x minus 2 upon 3 equals to t. That implies x is equal to 3t plus 2. Y minus 1 upon 2 is equal to t. That implies y is equal to 2t plus 1. Similarly, z plus 3 upon 1 is equal to t. That means z is equal to t minus 3. So this would mean that our parametric form is x, y, z. The vector equation is x, y, z, and your constant is 2, 1, minus 3 plus the parameter t with 3, 2, 1. This is the vector equation of this, the same line which has the symmetric form given to you like this. That's the relationship between the two. You should know how to represent any given line in symmetric form and parametric form. Thank you very much.